So hello to this demo of the Compose project. So the goal of the demo is to show how the data management work developed in Workpackage 2 works toward the creation of easy pipelines of data coming from Internet of Things. So the basic idea is that what we will be seeing here is we will be emulating the creation of a web object that is actually an internet connected device that will be talking to the Compose platform. It will be sending updates. We assume here that the web object, the smartphone, is actually enabled with a temperature sensor and a GPS, so it has temperature information and it also have geolocation. So the information that this device is collecting is being pushed to the platform, and then we will see how easily can be created as a thin client, a web layer, a thin client with a map that is actually showing for all different devices that we are emulating what's the current temperature that they are reporting for different places in all over Spain. So we will see in a map all the devices that we have, all the sensor updates that they have sent with their current position and the temperature that they are measuring, and we will create easily a map to show the temperature that people is reporting all over the country. So what's going to happen when we push and register the device? So this is the architecture of the data plane of Compose. So we have the end objects right here. We have a service objects API that is a REST API that communicates with the security model. This is the entry point for all activities related to data management. So when one of these requests for doing something with the data or just data flowing in from the objects arrive to the REST API, what it does is basically it decides either storing the data, if this is plain data that needs to be stored, and that's it. But then there could be people outside or inside of the platform that is interested in any updates that take place for that particular stream, for that particular data feed. So we have in the backend, we have Kestrel as a queuing system for storing updates that come from for keeping temporary updates that come from the clients, and then we have Storm, Twitter Storm platform that is actually the platform that you were using to processing the data streams. So based on the people that is subscribed, the entities that are subscribed to updates from this data feed, it dispatches the information to external or internal entities and then also stores the data. So we have also integration with Elasticsearch for providing analytics and queries. We will be leveraging actually Elasticsearch for doing geolocation. And we will have integration also in the future with work done in another work package in Compose that it has to do with semantic web, and we will have our RDFS store that will help us finding different devices in the platform. The first thing that we will do is we will register the service object in the platform. So this is basically the description that I was showing before. So you have to do post call to the API. So we are now ready to register. So we send the data. So we had an internal error. It has nothing to do with the demo. It's actually that we're in testing machines and they are a bit overloaded these days. So basically we have succeeded in the creation of the service object. So this is the ID of the service object, and it can be accessible through this endpoint, api-server.etc.com, and this endpoint here. So now we are ready to start looking at the data associated to this service object. So this is a basic map of Spain. So we can refresh. It's actually containing no data. So we are seeing here that we are reporting information from 0 sensors. So we have many other registered devices like this one, and what we will start doing is we will start producing data for one single point of data for this device that we created. So we generate the data. Yeah, there we go. So this is the data, this is the information that we have put. So now we come to the map, and when we reload, we will find this very first point, this very first sensor that is registered in the platform. So this is the first update coming from this sensor. So if we zoom in a little bit and we look here, we see the coordinates of the point, and this is the position that we have reported. So we can zoom out again. We have now one single sensor, and what we have implemented also is using Elasticsearch. You can do quick data queries. So we have implemented one query that is once you click on the map, you will see devices that are only within 300 kilometers around the point that you are clicking. So this red circle is actually pointing the 300 kilometers. So there are no any data feeds coming from these places, but you see the one from Madrid is reported whenever you are in those 300 kilometers around him. So we go to the general view again, and what we will be doing now is we will start generating data for different devices. So we will start creating data. So we will auto refresh every 5 seconds. You see now that some data starts appearing. So we can make the different geolocation views. So every time this is a geofilter. So it's actually only requesting data that comes from sensors around 300 kilometers from the position. This is not a visual filter. This is going to the database and asking for any element that is around 300 kilometers from the point in which I have clicked. So this is the current population of devices. So they are being emulated. We can see different temperatures. They have been generated randomly. And what we can do also now is with this simple map, come here and enable the heat map. So the heat map is going to show us what are the heat points in the country based on the information that people is actually reporting. So we could see here this heat zone around the south of Spain that is in some way expected, but not because the data is real, but it was randomly generated.